Today we're going to be discussing some of the common terms that we use as part of our introduction into the Technology of Coating Systems course. To begin with, substrate. Substrate is any product that can be coated. This could be poultry, beef, pork. It could be seafood, vegetables, even something as unusual as Snickers candy bars, which is what we've seen in the past. The coating. The coating is an enrobement material for the substrate. At the interface is the transition area between the substrate, establishes adhesion, and may provide texture. The coating consists of three different parts typically. They may include a predust, which is a substrate-dependent base coat that serves as the foundation for additional coating pickup. The batter, we use that term as a liquid application that builds a layering effect, providing adherence surface for any further applications. And the breading is the outer coating that provides most of the textural and visual attributes of a coating system. Some other terms that you're going to hear used today include browning. Browning is the heat-activated reaction that provides the color and flavor for the coated product. You may hear us refer to this as Maillard browning or even a non-enzymatic browning. This is a heat-activated, so it's what gives coated foods, fried foods, their flavor and their appearance. Our coverage is how the breading is distributed over the surface of a product. Good coverage means that breading is evenly coated, that it doesn't have any bare spots on it. Pickup is the percentage of a product that is a breading. It's a USDA defined term that defines the percentage of breading on a product. Hydration, we will talk to, is the ratio of dry mix to any liquid. Typically water is used, but it's not limited to that. You could use other types of liquids such as milk or anything else, potentially even beer or some other types of liquids. And viscosity, when we talk of hydration, it sets up the viscosity, which is the thickness or resistance to flow of the batter. Primarily, we bread foods to establish flavor. Coated foods embrace ethnic diversity while providing a platform for the delivery of innovative and new flavor systems. The earliest stages of coated foods included meat, flour, and lard to provide economical methods to retain calories before the times of refrigeration. Fried foods have evolved from this method of making lesser cuts of beef or meat and byproducts more palatable to a modern cooking method that's preferred by operators and by your consumers. It adds convenience by making foods more portable. This supports active lifestyles, creating finger foods. It improves the visual appearance and plate coverage in support of the phrase, "you eat with your eyes," or more accurately, "you purchase with your eyes." Coating a system also provides a thermal buffer. What this does is this is an example of a chicken that does not have a thermal buffer. It has no coating system on it. So what you see is the effect is a very hard outer shell that shows the scorching that that'll result from a direct contact with the heat, in this case oil. Also what this is, without being able to control the migration of moisture out, is that moisture escapes this surface. The interior of this chicken is going to be very dry, the outside is going to be very hard. This will not be a product that would be appealing to you or your customers. Southeastern Mills is historically known for their strength in flour milling. We have flour mills across the country, including the Southeast, the Pacific Northwest, and even as far as Hawaii. From this, we're able to take advantage of the regional differences of flour and be able to take those, combine them, and give you the textural attributes that you look for as well as your customers seek. There's several different types of flour that we use, and I'm going to walk you through each of these. Typically, what we have, the most common form of flour is soft red winter. That is grown pretty much across the country, out in the Midwest and out to the southern states. And that is primarily what we mill here in the Southeast at Southeastern Mills. It provides a nice value point and gives some nice functional attributes that are preferred in coated and fried foods. Another type of flour we have available is hard red winter. That is your Kansas wheats typically, the ones that are grown out in the Midwest. These are typically flours that are thought of when you think of bread flours. Hard spring is your northern up into your Dakota area. Those are those types of wheats that are even up into Canada. Typically your higher protein flours, where your soft or your lower protein flours. We'll talk a little bit more about what protein does for you and how you can take advantage of different levels of protein, and in some ways how we can take advantage of the different characteristics that flour has across the country. Some of the others that are listed here are durum, which is typically associated with pasta, hard white and soft white. These are less geographically available, but the hard whites are grown typically up in the Dakotas, up in the northern areas, out in the Pacific Northwest, and they have done some experimentation with it in other areas, including Kentucky. The soft whites are pretty regional. They're Pacific Northwest also, and are grown in the Great Lakes areas. So these are the types of flours that are commonly used in coating systems. Visibly, you can tell the difference in each of these. This right here is the span of flours that you have available. This is the soft wheats. You can feel the differences here in these wheats. And the old millers used to do a test that would be able to help distinguish what type of flour you're using, which is just a clinch test. If you make a fist and a ball, if it holds together, that's pretty representative of what a soft wheat will do. It takes a little bit of effort to break it up. Where hard wheat is a little bit at the same granulation, these are all the same granulations of flours, but this one wants to be more free-flowing. It holds into less of a ball. It breaks up more easily. And spring is your most free-flowing of all. The highest protein, it's hard to make it hold into a ball. You have to squeeze really hard and it falls apart very readily. With the higher proteins, you get higher absorption rates than you would expect with a soft protein, or with a low protein flour, soft wheat flour. And this could be seen as a hydration. These hydrations are done as a 2-to-1 hydration. You can see that this one makes a fairly thin batter. And all this is flour and water. What you see here is your hard wheat, and you start to see more viscosity here. It's a thicker batter. And your spring is your thickest, and it shows the highest viscosity. Your soft wheats, because they're the most widely available, the lowest proteins, these are typically your least expensive flours. Hard wheat is typically in normal markets your next, and your spring or your premium flours, your high protein flours, they're typically your most expensive. So it would be natural then to assume that we'll just formulate with the soft wheat flour because it's going to be the lowest price. But the difference you see here starts to represent the challenges we have as we start to formulate products. This, even though it's the cheapest, will require more flour to be able to achieve a viscosity that you would expect to see in a spring flour. So when you do that, when you start to talk about different flour selections, we may want to choose flours that give you different textural attributes. You'll start to see when you formulate with soft flours, it gives you, coincidentally, a softer bite. Where spring flours, higher protein flours, will give you a tougher bite. It is more resistant to tearing. So we would pick flours that meet the attributes that your customers are looking for. In this case, we could even do combinations to be able to combine different textural attributes to get you something that would have a crisp texture but also have a resistance to bite. So this is the things that we do as we select which flours are most appropriate to your application. One of the other things that is striking with flours that's noticeable is you can visually see differences as you test your flour. I'm going to do a quick little test here, and I hope this shows up on camera. But what you're going to see is visual differences that are represented by different types of flour. The soft wheat is typically the whitest. What you see here is the lighter color. Your hard wheat is a little bit darker. Your spring wheat is typically the darkest. Now what this starts to represent is ash content. Ash content, the lower protein flours typically have lower ash flours. The higher proteins typically, and there's exceptions to this, there's different ways to achieve ash. That's why I would caution you as you start thinking about ash. A lot of companies, a lot of people will rate their flours based on ash content. I would tell you that there's a lot of ways to achieve ash content, and that does not necessarily tell you much about the choice of flour you're making. I could get an ash content that's much higher that does not tell you anything about what type of flour you would get or what characteristic you would expect to get in a finished cooked product, because we can take different streams of flour, combine it, and hit ash targets. So I might be able to add more of a higher ash flour to this. It make a cheaper flour, but it may not get you the attributes that you want when you start to get ash contents of a spring flour. You wouldn't get the same textural attributes, you may not get the same absorption. So I caution you as you talk about that, it's oftentimes more to your advantage to speak of flours of what characteristics you want rather than what perhaps ash attributes. If you can speak to protein, protein starts to tell you a little bit more about the quality of flour and what you might want to select. As I've described the different attributes of flour from the physical appearance, let's also talk a little bit about what the functions of these flours have been traditionally. When we speak of hard flour, these are your typical bread flours. If you go to the grocery store, buy a loaf of bread, that's typically going to be made out of hard wheat flours. The soft wheats are typically flours that you would associate with biscuit manufacture or crackers, or in some cases cookie manufacture. These are your more common flours, and they're known specifically for those types of applications. Spring wheats now are a little bit of a special category of the hard wheats. They are your high protein flours. So when you think of spring wheat flours, you're thinking of the French rolls, the hard breads, the pizza doughs, the very elastic types of doughs. That's what these types of flours are used for, and this is functional of the higher gluten content of these flours. The semolina and the durum flours, they are pasta flours, typically not used in coatings because they really give you no advantage. From time to time you will see those applied in pasta manufacture. One of the other things that I'd like to talk to is protein. We talked about ash, we talked about protein. Let's talk a little bit about what the protein does for a coating system. With the hard wheats, the higher your protein content, it changes the flour to have an effect on the texture of the product. Typically, the higher the protein you get, the tougher your bite is, the more resistant to tearing. On your slide it says crunchiness. I would refer to it as almost a toughness, as opposed, it gives you resistance to bite. It can give you a crunchy bite, but it's a bite that forms less crumbs. If you want a less crumbly product, higher proteins would probably be suitable for you. If you want something that gives you more shatter, more delicate bites, particularly appropriate to longer fry times, softer wheats are going to be more appropriate. One of the other things that we can do with flour speaks to bleaching of flour. Now typically when we talk of bleaching we view as being a method of whitening flour to make cakes whiter, make breads whiter. But bleaching also has other functions than just whiteness. You can add bleach in the form of a chlorine, which is a form of bleach that's commonly used on flour. What this does is it lowers your pH. Now without getting too chemical, what that functionally does is it enhances the protein of a flour. So it's typically used in cake flours, so that flour is able to support the weight of the sugar that's in there. What you would expect to see with a chlorinated flour, if you think of a biscuit or a cake, is you get rise out of it because the chlorine's in there. It has a lower amount of protein, but those proteins are more functional, so it goes up rather than spreading out. Where if you had a higher protein flour without the chlorine, you would expect more spread. So that becomes a functional attribute. Now how does that affect us when it comes to coated systems? With more functional protein, you get harder bites. You can call it a crunchiness, but it's also, at the extreme level, it can be a hardness, which helps things stand up better on steam tables or extend shelf life of cooked products.